when finished components, such as these twist drills, arrive at the end of the production line, it's difficult to imagine just how many people have been involved in making them. Producing drills, like anything else in the engineering industry, involves a lot of people. Some work on the shop floor, like the craftsmen, while others, whose jobs are just as essential, work elsewhere. One person whose job involves a lot of travelling is the technical representative. In this firm, he's responsible for investigating any technical problems customers may be having when using the firm's drills. The problem at this factory concerns the drilling of deep holes in a material using the only suitable drill so far available. Through discussions with the foreman and through watching the operation himself, the representative gets as much information as possible.
Well, now, sir, what exactly is the problem with the drill?
Well, as you can see, it's a 1-series drill, standard 1-series, and we're getting quite a problem with clogging up. As the drill goes down, it isn't quite cooked properly.
And you expect the drill is slipping in the track, is it?
Yes, that's what it is. Sometimes we'll have breakages through this as well.
I see. Well, what I would say the problem is on this one is because you're drilling to the full depth of the flute, it's preventing the swarf coming away sufficiently well, it's clogging in the flutes, which is causing the slipping and possible breakage. Now what I would like to do is take this back to our factory and let our design people have a look at it, see if possibly we can come up with something.
I see, yeah.
While the technical representative is discussing the problem with the design people, the management meet to decide whether there's a need to develop a special tool for drilling deep holes, and if so, if there would be a market for it.
Mr. Chairman, I'd like to ask Jim how big a problem this is. Are we getting, for example, just 1 or 2 complaints, or are we getting several dozen complaints? And also, has this just cropped up, or is it something which we've had for a long time? Jim?
No, I would say that this is something that has been with us for a long time, but of late we appear to be getting more and more demand for a tool of this type.
Chris, how do the export markets react?
There is certainly a requirement on all industrial markets for a drill designed for deep hole drilling. It's becoming more and more of a problem. It's not so much a question on export of complaints as of the need existing, and if we can find some new drill that will overcome this problem, obviously it will help us to promote our general drill program.
Yeah. But you've heard the problem. Have tool development any ideas to put forward at the moment?
The standard range of drills that we market for drilling deep holes is, of course, the standard flute geometry. That is a chopper drill or a standard taper shank drill. Standard procedure is to back the drill out of the hole. Engineers are wanting to get away from this. I think with a quicker spiral and a wider flute, we would probably be able to drill deep holes without the need for peg feeding.
Derek, from what you've heard, can you now run a market research program?
Well, I'll initiate a full market research program utilising our representatives here in the UK and also any of our representatives abroad. First of all, to establish what size of market there is for this type of tool, what percentage of this tool is required for deep holes rather than long reach, and also in the course of the research I'll try and establish what are the most popular sizes and pass these on to Bert while he's started to prepare prototype tools.
Bert, the tool development engineer, next discusses the idea with his assistant.
We want to drill with a very quick spiral. It must have a very wide flute.
What he's drawing here is the land. The flute of a drill is the spiral channel which allows the swarf to get out of the hole.
We want all this area taken away to provide maximum flute space and thereby get a good evacuation of swarf, because this is the problem with deep hole drilling.
If we do that, this will make the drill much weaker, and we'll have to build some strength back into the drill by possibly having a strong core on it.
Yes, I already considered that. The core thickness, of course, on the new drill will be much thicker than the standard drill.
Yeah.
But what I suggest is that we start with, say, 0.5 times diameter at the small end of the range to 0.45 times diameter at the large end of the range.
And that will make the drill much stronger.
Well, I suggest that we start making some manufacturing drawings to this idea and get cracking making some testing.
Yes, we'll do that.
Once Bert's assistant has produced a manufacturing drawing, it's not long before the first batch of test drills can be made. This is where the craftsman comes in, on the shop floor. A machine tool setter prepares a special milling machine that will be used for cutting the flutes of the drill. These gears will determine the type of spiral that's produced. Many of the items required, including the milling cutter, are kept in the stores. Before they can be withdrawn, a store's requisition has to be made out. This not only tells the storekeeper the type of milling cutter required, it also gives him a written record of when and where the tool was taken. Working from a rough layout sheet, the setter adjusts the angle of the milling head to give the correct helix angle for the drill. Next, the milling cutter is mounted on the spindle of the machine. This device is called a collet. It's used to hold the steel rod, which will eventually become the drill blank, if you like. Everything must now be checked. Then it's only a matter of time before a batch of drills is ready for testing. Flute milling is one of several processes the drills must go through, until finally they're ready for point grinding. If we compare one of these new drills with a standard drill, you can certainly see the difference, particularly in the size of the flutes. Now to test the difference.
John, that sounded awful. Let's try this new drill under exactly the same conditions.
The conditions involve trying to drill a deep hole without stopping to clear the swarf. With the standard drill, this resulted in clogging and failure. What will happen with the new drill? Straight through in one go. It looks as if the new design could be a success. But that's only the result of the firm's own test. At the same time, many of the customers have also been testing the new drill. Have they come up with the same results?
As you know, we've had samples out in the field, and I think the first thing we should do...
Once the results of all the tests are known and the market survey has been completed, a management committee has the job of deciding whether or not to go ahead and produce the drill. The committee first discusses the test results.
You have the reports, I believe.
Yes, in terms of drilling time and drill life, our test results both in this country and in industrial markets overseas show that drilling efficiency is enormously increased. against the standard long series drill. Drilling time has generally been at least halved, and in some cases drill life is up to 5 times improved.
Derek, would you like to give us your report on the size and scope of the market now?
Certainly, yes. The market survey, carried out in conjunction with the field trials, shows there is tremendous demand for this type of product, and potential sales are shown as a percentage of the long series sales on the report that I think everybody's got a copy of.
Bert, do you anticipate any alteration in design of the tool?
I'm more than pleased with these field test reports. They confirm our own internal tests. I don't envisage any further development work. I think we can consider the long series ranged design now complete.
It seems to me, at any rate, that this is a very successful trial. The tool seems to be a good one, and I would put it to the meeting that we definitely should go ahead and market this. What's everyone feel about this? Are you in agreement?
Yes, certainly.
It's been suggested regarding a name for this product that we might call it the worm pattern. Perhaps, John, if you could get the marketing committee to have a look at this and see whether they think it's a suitable name.
Yes.
We must find a name for the new product before we launch it. The other thing, of course, which we've got to look at is a launch date.
With the decision taken to go ahead, a senior draftsman has the job of producing a master drawing of the new drill. This drawing is highly detailed and will eventually include such information as the tolerances in dimensions and the type of material to be used. Once the master drawing is complete, it goes to the print room for copying. One of these copies goes to a planning engineer who uses it to plan the sequence of operations that will be necessary to produce the drill. Another person who needs a copy is the tooling design draftsman. He prepares the drawings of all the jigs and fixtures that will be needed on the production line.
Now let's have a look how we've amended these.
Also involved are the people in the publicity department, preparing information leaflets and advertising literature.
This is for the grinding instructions, is that correct?
Yes, that's right. The drawing office are doing those.
Uh-huh. Now what about colour on this particular one? I think it's fairly obvious, but...
Oh, I thought I'd have that done in red.
Yes.
And then do that in red also to emphasise it.
Okay, we'll have 6,000 of those, I think, to start with. Now let's have a look at the advertisement. Yes, that looks better with the... Oh yes, I like that much better with the...
No, you've dropped that.
Dropped?
Yeah.
That's fine. That looks nice. And the dovecoat
Centred.
moved away from the dormer and centred. And leave the dormer in black in this
Yeah.
instance, yes. We could put this in metalworking production, machinery, engineer's digest.
Okay, I'll put the wheel on now, Rachel.
On the shop floor, a work-study engineer is busy looking at the time taken to machine the flutes of the new drills. A grinding machine, like this one, is used to produce the flutes on the smaller diameter drills. The whole process, from loading the wheel to finishing a batch of, say, 100 drills, will be very carefully timed.
Good morning, gentlemen. This meeting is to discuss the manufacture of the new deep hole worm pattern drill.
Before the drill finally goes into production, the management meets the foreman for the job, the works convener, and the shop stewards to discuss and answer any questions they may have. One point they'll no doubt want to discuss is the result of the work study. It was found that the new drill took longer to produce than a standard one of the same length. This would mean that the operators would have to be given more time in which to earn their bonus.
Present time. Think about any repercussions of this, discuss it with your members, and if there are any problems or questions, don't hesitate to come and see me and we'll try and sort them out.
Production can now begin. The steel rod bought in for the job must first be cut up into the right lengths to form the drill blanks. This is done in a single spindle automatic machine. The steel rod is parted off in such a way that one end is pointed while the other end is cut square. The pointed end will eventually become the point of the drill. Once cut, the blanks are loaded in the flute grinding machine.
Hi George, how are things?
All right.
Good. I've worked out...
But is George satisfied with the bonus figure that's been worked out for flute grinding the new drill?
By performance. How's that with you?
Oh, that's quite acceptable.
As far as I'm concerned, it's quite normal.
It's quite good, yes.
Okay?
Yes.
Right.
The flute grinding is also done automatically. All the operator has to do is to keep the machine loaded with the right number of blanks, change the grind wheel when necessary, and generally keep a watchful eye on things to see that nothing goes wrong. Once the drills are in production, a periodic check must be made to ensure that the drill is meeting its design requirements. This is the job of the inspector. Using suitable measuring instruments, he carefully checks every feature of the drill. The results are plotted on a specially prepared chart. If the measurement lies between the two inside lines, it's within the degree of tolerance allowed. While the flutes of the smaller diameter drills are machined by grinding, the larger diameter ones are milled. In another department of the firm, orders are coming in for the new worm pattern drill.
Good morning, sales department. Can I help you? Yes, can you hold on a moment, sir?
Before answering a customer's request, the service manager checks with the finished parts store to make sure the drills are in stock.
Have you got 100 5/32 worm pattern drills in stock, please? Thank you very much. Hello, sir. Yes, we have these in stock.
Before going into stock, the drills are dipped in a coat of oil to prevent corrosion, sorted into bundles of 10 and packed in boxes. The customer's order goes down to the dispatch department. Here, the boxes of drills are withdrawn from stock, weighed and packed into a suitable container. Along with each order goes a delivery note. This helps the customer to check that he's received what he's ordered. If the customer is near, the order will probably be delivered by the firm's own van. Inside, the new drill is already in use. The operator has found it will produce over 1,000 holes. That's 5 times the life of a standard drill. What's more, it'll produce a deep hole in one go, without stopping to clear the swarf. This means he can get on more quickly with his job, making more components in the same time. A whole team of people was involved in the design and production of this new drill. As important as anyone in this team was the craftsman.